This is a rose. And this isn't. You can't scratch and sniff a YouTube video, at least not yet, but I bet you imagined how these smelled the moment that you saw them, didn't you? But can you imagine what this smells like? Unless you mastered high school chemistry, probably not. But a molecule can tell you some interesting things about itself, and by the end of this video, you will know how a molecule's chemical structure can help you make predictions about its scent, just by looking at the functional groups it contains. How cool is that? So what's a functional group? It's a pattern of atoms that allow us to predict some things about how a molecule, wait for it, functions. Yes! Regardless of the exact molecule they're found in, functional groups can help us learn a little about a molecule's behavior, what it might react with, its boiling point, whether it likes water or not, and what toppings it prefers on its pizza. No, not that last one. Scientists write the functional group and then they use the letter R as shorthand to refer to the rest of the molecule, because no one wants to write the rest of a potentially large molecule if they don't need to. But wait, why are we getting a chemistry lesson from a girl who talks about beauty? Because these functional groups will help us start to visualize odor molecules that will later help us understand perfumery. So we're going to start this lesson by having a little fun. Here's some functional groups that are real stinkers. So our first smelly compounds are those that have a carboxyl functional group, which is a carbon atom double bonded to an oxygen atom and single bonded to a hydroxyl group at the end of a chain. They're found in fatty acids, and those that contain 4 to 10 carbon atoms all have the typical smell of sweat. If we modify the hydrocarbon region of the molecule by adding carbons to the length of the chain, we can get these variations which can contribute to the unique odor of each fatty acid. There's butyric, valeric, caproic, caprylic, and capric for capra, the Latin name for goat. However, the main repulsive smell in these molecules is due to the carboxyl functional group that dominates in all these compounds. Then there is the thiol functional group. They are compounds where a sulfur is bonded to a hydrogen. You might recognize thiols from my recent video collab with the American Chemical Society on perms. I mentioned how they're what give perms that horrible sulfur smell. They have extremely strong, stinky scents and are often associated with decay because they're the decomposition products of proteins. When amino acids like cysteine and methionine decompose, thiols are formed. Eating a decaying animal could make you sick, so it's an evolutionary advantage to detect and avoid eating rotten meat. So our noses are very sensitive to thiols. Examples include methane thiol, which smells like rotten eggs, propene thiol, which smells skunky, and ethane thiol, which smells like rotten cabbage. They're so effective at sending an alarm signal to our brain that methane thiol is added to the otherwise odorless gas in our stoves, so we snap to attention when there's a leak. And now we come to another group of repulsive odors. Molecules containing the amine functional group always seem to be gross regardless of concentration or context. Amines contain 1 or more nitrogens. The molecules that are below 7 carbon atoms have very repulsive odors. There's the foul-smelling putrescine with 4 carbons, which contributes to the smell of bad breath, and along with spermine, contributes to the odor of a certain male bodily fluid. There is also cadaverine, which smells like rotting flesh, which may be why the feces of carnivorous animals like cats and dogs smell stronger than those of herbivores like rabbits or sheep. Or try methylamine, which smells like stinky fish or urine. P.U. You would never see these stinky odors in your perfume, right? Well, imagine my surprise when Old Spice's master perfumer Zerlina Dubois mentioned to me that using tiny amounts of thiols in scented products help the aroma stay noticeable and fresh over the course of the day. In fact, it's not uncommon to have musks or indoles, molecules which often are described as fecal, carefully added to a fragrance to mellow out the heady floral scents. Fragrancers do use functional groups and structures to make educated guesses about how a molecule might end up smelling, but to be honest, it's far from a sure thing. How the molecule will actually smell when used can depend on a lot more than just the functional group. Let me show you what I mean. Check this out. These two molecules have the same functional group. They look nearly identical, so they should smell the same, right? Spoiler alert, they don't. And then we have these 4 molecules, which look nothing alike, and yet somehow they all smell like musk to us. Chemistry is so weird. Famed perfume chemist Charles Sells was so vexed by these challenges that he wrote a paper all about it called On the Unpredictability of Odor. So what's the verdict? Knowing the functional group can give us an idea of what scent we might expect from a molecule, but it's no replacement for the nose. A scientific instrument we'll be exploring more soon. The good news is we learned a bit about functional groups and the role they play in molecules, which if you want to learn more about chemistry and how it relates to fragrances is a pretty great thing to know. If you want to learn more, check out the next video on fragrances right here.